Hey guys, welcome back. So, in the last module, we built something useful. We took our documents and we built BM25. Now, when a user asks a question, BM25 can search through our documents and find the document that is most likely to contain the answer. But there is still a problem. BM25 can tell us this document is probably relevant, but it doesn't necessarily tell us this exact section inside the document contains the answer. And this becomes a big problem when our documents are large and highly structured. Imagine you have a 500-page technical manual, or a legal contract with hundreds of sections, or a financial report with chapters, sections, tables, and footnotes. Now imagine PM25 finds the correct document. That's great. But what happens next? The document might contain hundreds or even thousands of occurrences of relevant words. For example, BM25 might find the word corrosion on page number 12, then page 87, then page 245, and then page 412. It knows the words match, but it doesn't really understand the document's structure. It doesn't know that the answer is actually inside chapter 4, section 4.2 and subsection 4.2.3. And this is where page index comes in. Page index gives us a completely different way to look at the document. Instead of treating the document as one giant block of text, we first look at its structure. We look at the headings, at the chapters, at the sections, and the subsections. And then we build a tree. Think about the table of contents of a book. For example, car manual. And the table of content looks something like this. Now this is our document tree. And now, instead of searching the entire document blindly, we can navigate through this tree. So the basic idea of page index can be understood in 4 steps. Step 1. Extract the headings. Step 2. Build a tree from those headings. Step 3. Navigate the tree. And step 4. Reach the right section and extract its content. That is it. Those 4 steps are the foundation of what we are going to build. Now let's look at each one. First, we need to understand the structure of the document. So we open the PDF and look for headings. For example, these are my headings. These headings gives us something that is extremely valuable. They tell us how the document is organized. We can identify the heading text, its level, and where it appears in the document. So instead of seeing, here is a huge PDF with thousands of lines, we start seeing, here is the structure of the PDF. And that is the first step. Step 2. Once we have the headings, we need to organize them. We need to figure out which heading is the parent and which heading is the child. Which section belongs under which chapter. And this is where we build our tree. For example, here 1.2 system architecture is the parent, and 1.2.1 components and 1.2.2 data flow are its children. So we are converting a flat list of headings into a hierarchical structure, and that tree is what page index will eventually navigate through. Now we actually build this tree in Python, and we are going to study something called stack algorithm. Don't let the name scare you. The stack algorithm is simply a useful way to keep track of where we are in the hierarchy while we are processing the headings. For example, if I see 1, 1.1, 1.2.1 or 1.2.2, we need to understand when we are going deeper and when we are moving up the tree. The stack helps us keep track of those parent-child relationship. And this is important. The stack algorithm itself is not the important part of page index. We are studying it because it helps you understand how the tree can be created. Once you understand the idea, you don't have to memorize the algorithm, and if you already understand the tree construction, you can even skip this part. The important thing is that at the end, we have a correctly structured document tree. Step 3. Now we have our tree, and this is where things become interesting. Let's say the user asks, why is my brake pedal going all the way to the floor? We have our car manual, and our tree looks something like this. Page index starts at the top. It says Chapter 1 Engine, Chapter 2 Brakes, and Chapter 3 Electrical. These are our choices. And now the LLM looks at the question. Why is my brake pedal going all the way to the floor? The LLM thinks, brake pedal? That sounds like braking system. So it chooses Chapter 2 Brakes. Page index moves into that branch. Now step 3 is going deeper. Now page index looks at the children of chapter 2. We have 2.1 how brakes work, 2.2 brake problems. Again, the LLM looks at the question. Why is my brake pedal going all the way to the floor? It thinks, this sounds like a problem with the brakes. So it chooses 2.2 brake problems. And now, page index has moved from car manual to chapter 2 brakes, and from chapter 2 brakes to section 2.2 brake problems. Step 4. Now page index checks, does section 2.2 have any children? If it does, we continue navigating. If it doesn't, we have reached a leaf node. A leaf node is simply a node that doesn't have any children. For our study in this module, we are going to make one simplifying assumption. We'll assume that the actual content lives only at the leaf node. In a real document structure, content can exist at different levels. A chapter can have content, a section can have a content, or even a subsection have content. But to keep our implementation easy to understand, we are going to assume parent node is only meant for structure and leaf node has the content. Now this assumption makes the navigation and extraction process much easier to understand. Later, you can extend the system so that content can live at any level or every level of the tree. So we have reached our leaf node, for example, 2.2 brake problems. Now we need the actual content belonging to this section, and this introduces another important problem. How do we know where section 2.2 starts and where its content ends? Well, we can use the headings themselves. Suppose our document looks like this. 2.2 brake problems, and then we have content, and then we have another heading 2.3 brake maintenance, and then again brake maintenance have some text. We know that 2.2 brake problems start here, and then eventually we encounter 2.3 brake maintenance. So we can say, start extracting the content after 2.2 brake problems and stop when we reach the next heading at the appropriate level. So we can say that start extracting after 2.2 brake problems and stop when we have reached the next heading at the appropriate level. Everything between those two headings belong to our section. Now this is something that we are going to implement in this module. We will build the logic that essentially says, find this heading, then Start collecting the content and continue until we find the next relevant heading. For example, start 2.2 break problems and extract content and stop just before 2.3 break maintenance. Now we have the actual content for section 2.2 and that content can be passed to the LLM. So now let's put everything together. Page index starts with the document. First, we extract the headings, then we build the tree. Then the LLM navigates the tree and chooses the most relevant branch. Then we continue navigating until we reach the appropriate leaf node. And finally, we extract the content from that leaf. So our process looks something like this. From PDF, we extract headings. From those headings, we build tree. From that tree, we choose branches to navigate. And then we reach the leaf node after navigating and extract the content. Then we send the content and the question to LLM and the LLM answers. And that is page index. Now let's understand how BM25 and page index work together. But remember, we are not replacing BM25. In fact, we are combining the two approaches. That is very important. BM25 and page index have different jobs. BM25 works at document level, whereas page index works at document navigation level. Imagine we have 1000 documents. The user asks, what causes break failure? We don't want page index to navigate through all 1000 documents. That's unnecessary. First, BM25 searches across all the documents and identifies the most relevant ones. For example, document 17, document 42 and document 89 contains the answer or is the most relevant document. We can take the top documents from BM25 and then we give those documents to page index. Now page index doesn't have to search through entire document collection. In fact, it only needs to navigate inside the documents BM25 already identified. So our pipeline becomes something like this. User question. Now BM25 takes the user question and thousands of documents. Now BM25 retrieves the top relevant documents. Then we give these selected documents to page index. And page index navigates inside these documents and find the relevant section. After we find the relevant section, we extract the content and we give this content to the LLM and LLM answers. Obviously, it will always need the question or user query. Think about the jobs this way. BM25 says, which document should I look at? Page index says, where inside this document should I look? And LLM says, based on this content, what is the answer? I want you to remember one simple analogy. Page index is like a GPS. If I tell you the answer is somewhere in this city, that isn't very helpful. But if I tell you, go to this building, that's better. And then go to the third floor, even better. And then go to room number 305. Now you are at the exact location. And that's what page index is doing with a structured document. It navigates. And once we reach the right location, we extract the content. So in this module, we are going to build the system step by step. First, we'll learn how to extract headings from a PDF. Then we'll learn how to represent those headings as a tree. We'll study the stack algorithm so you understand how parent-child relationships can be created from a sequence of headings. Again, you don't need to memorize it. You can skip it if you want. It's there to help you understand what's happening underneath the system. Then we'll implement the tree navigation. We'll give the LLM the available branches and let it choose which branch is most relevant to the question. Then we'll navigate until we reach the leaf node. And finally, we'll extract the content between the current heading and the next appropriate heading. And remember our simplification assumption for this module. We are assuming that content lives at the leaf node. In a more complete implementation, content can live at any level of the tree. But for learning purpose, we'll keep our model simple. First understand the tree, then understand the navigation, and then understand the content extraction. Once those concepts are clear, you can make the system more sophisticated. Let's quickly summarize what we have learned. First, we extract the heading. Second, we choose headings to build a tree. Third, the LLM navigates that tree by choosing the most relevant branch. And fourth, we continue until we reach the appropriate leaf node. Fifth, we extract the content belonging to that section by reading between the relevant headings. And finally, we give that content to the LLM to answer the user's question. And remember, BM25 and page index are not competing with each other. They solve different problems. BM25 finds the right document and page index finds the right location inside the document. And that is the foundation of retrieval system we are building. So now that you understand the big picture, let's start building it. We'll begin with the first step, extracting the headings from the document. So let's get started. I'll see you in the next lesson.